Hi, good morning everyone, and welcome to the webinar on cloud computing. Today we'll discuss what is cloud computing, what are the different forms of cloud computing, in terms of the deployment models, in terms of, players which are available in the market, and most importantly, we'll cover where AWS stand in terms of cloud computing. So today's agenda is going to be discussion on cloud computing, followed by the service models and the deployment models of the cloud computing, and how cloud computing, is advantageous in comparison to your traditional, data center environment, and what are the typical use cases for cloud computing, especially in case if anyone wants to move their environment or move their workload onto the cloud, then what are the options available to them and how they can start moving the environment over to the cloud as well. And then we'll also discuss about some of the cloud providers which are prevalent in the market and what are the demands for AWS. And in case if anyone is interested in pursuing their career in cloud computing or in AWS, then what are the options available for them as far as learning is concerned. All right, so before cloud computing, so anyone who has worked in a data center environment or let's go 5, 7, 10 years back, typically what would the process be in case if you want to host a website or in case if you want to host a web application or if you want to host any application for that matter, then what was the typical process that we used to follow? Well, the typical process was, first of all, there was no clarity in terms of sizing of the infrastructure. So typically, let's say if you want to deploy a website or if you want to deploy an application, normally you will have to rely on developers' inputs in terms of what is the capacity of server or what is the number of resources that you want to deploy that application. So those resources can be servers, those resources can be storage, those resources can be database licenses and so on. And typically, developers are someone that, they may be good in developing solution or they may be good in programming languages, but then usually do not have any idea about the infrastructure. So typically what would happen, they would guess a capacity based on, if somebody has deployed it somewhere else, then they will just take a guess that this particular application was running on XYZ environment and they are using this capacity, so let's go ahead and order this capacity. So that was the capacity sizing part. So mostly it was guesswork. Then let's say if we have decided that these are the resources that we want, then we need to buy a stack of servers. So let's say we need 2 servers, 3 servers, 5 servers and so on. Who will be normally responsible for buying the server? So there is another team who would be responsible for procuring those assets. So of course you need to take approvals. So you need to take approvals from your accounting department, you need to take approvals from your business unit heads and so on. Once the approvals are in place, then you need to place an order. So who will place an order? Again, there is another team, which is a procurement team who will place that order. And there are again multiple vendors. You can purchase those servers from HP, from IBM, from Dell, and so on. Now, typically, as I said, your sizing, whoever does the sizing, they're always keeping their peak traffic in mind. So peak traffic is not important that your web application or your website will always be at peak demand, because normally your demand always fluctuates. So let's say that if you're an e-com store, normally, there is a trend that whenever there are some festivals around, you will receive more traffic during festive season when people buy more products, right? And rest of the days your demand would be pretty much less. But in case if during the capacity sizing, during that guesswork, if you have guessed it wrong and suddenly you are seeing that you are hitting more traffic than you expected, then again you need to buy more servers, right? So all of this thing was a lot of headache, a lot of pain, and a lot of guesswork was involved in sizing your environment. And of course, how would you know that whether you are hitting the peak traffic or not, or whether you need more servers? So you need some kind of monitoring environment. So somebody was responsible for monitoring your servers. Somebody is responsible for maintenance of your servers. So typically you will have a maintenance agreement with your OEMs. So maintenance agreements with companies like IBM, HP, Dell, and so on, from where you have procured those servers. And then of course you also need to have in-house staff as well, who is responsible for updating the patches, updating the making sure that all your security updates are in place and so on. So as you can see that before cloud computing there was a lot of hassle, and typically the process of deciding to buy a server to the point when the server is actually ready for the developers to develop an application or deploy an application or deploy a website, the typical period was around 4 to 6 weeks, and at times it may be more depending upon the company that you're working in, depending upon the approval processes in place, and depending upon how quickly that servers are available with your OEM or not, or your resellers or not, and whether those servers are available directly in the warehouse or they are getting it directly from the OEM. So typical, 4 to 6 weeks is a standard time that we used to take before, buying a server or before the server is getting ready for your deployments. Now, of course, there are a lot of disadvantages. The setup was very expensive because we have said that there was a lot of guesswork involved in the capacity sizing of your environment or capacity sizing of your servers. So one scenario was that you have guessed it wrong and you are hitting a peak usage and your current server capacity is you're not able to support your peak usage. In that case, you need to buy more servers. Another scenario can be that you have oversized your environment, you have over provisioned your environment, you have bought more servers or more storage than was actually required, and now you are not hitting that much of usage, and then you're lying with these servers sitting idle at your environment, but you are not able to make any use of it. And after 3, 4, 5 years, normally each and every infrastructure hardware that we procure, they follow some kind of life cycle. So typically in IT environment, 4 to 5 years is a refresh cycle associated with all those environment, whether you talk about storage, you talk about network, you talk about servers and so on. So if you are not able to make use of the infrastructure that you have procured, after 3 to 4 years, you will anyway have that infrastructure will be depreciated and you again have to procure a new one. So of course, this setup is very, very expensive. In case of troubleshooting, your troubleshooting problems can be a very tedious task and may conflict with your business goals. So as I said that there are multiple parties involved. So there is a monitoring environment, again, depending upon whether you want to invest on the monitoring tools and you want to keep that monitoring environment in-house, or you want to outsource it to some third party. So there are again multiple providers or multiple companies available in the market who provide monitoring and management services for your infrastructure. But of course, that's again a costly affair. And then depending upon what your business goals are, whether you really want to invest in the skill set for monitoring and managing all those environment in-house, or whether you want to focus on your core business and you want to outsource all this monitoring and management environment to the third party or not. And even if you outsource it to a third party, in case of any problems with your website, in case of any problems with your application, you have multiple parties to talk to before you can find out whether whether the problem is with your code, whether the problem is with your network, with your storage, with your internet service provider, or whether the problem is with the hardware as well. Troubleshooting is quite a pain in that kind of environment. Since I said that most of the time, any application, any website, your traffic is always varying. So there is no fixed demand as far as your application or as your website is concerned. Normally they go from various phases. So there may be time that there is no traffic or there is very less traffic on which is hitting your website or your application. And there may be time, which we normally call it as peak usage, that the demand surges and you really need to make sure when you're hitting the peak period, you have enough infrastructure in place to take over your load, because any customer lost due to non-availability of your servers is a business lost. So your servers will be idle most of the time if you have over-provisioned it, but at the same time we need to make sure that we have enough capacity in place, especially during peak hours. So how do we fix this? Well, the answer to all your problem is cloud computing. So what do we do after we have cloud computing in place? First of all, rather than putting every infrastructure or every server or every storage, networking, etc. in our own environment, we put all our data on cloud servers, and there is no more buying of expensive servers, because most of the cloud computing, irrespective of the provider that you choose, irrespective whether you're going for a public or a private and so on, most of the cloud computing providers, they offer you OpEx model. So rather than putting upfront costs associated with procuring your hardware, you can normally break it down into your operational expenses. So if we talk about the public cloud providers, most of the public cloud providers, they the pricing for their servers is normally in the range of per hour, or some of the providers also provide per minute billing as well. But let's make it a baseline that each and every public cloud provider will bill you your server usage based on per hour per month. Okay. So there is no more expensive hardware or expensive servers to buy. There is no upfront cost associated with it, and you can terminate those servers as the moment you want it. So for example, again, even if there is a guesswork involved, so you will provision those servers, you will monitor the usage of those servers. In case if you are making use of the servers that you have provisioned, you can continue to use it. If you are not making use of those servers, if those servers are sitting idle, you can terminate those server instances, and without having to worry about any residual cost in that case, because you're only paying for the capacity that you're using. So if you have only used it for 4 hours, you will pay for 4 hours. If you're using for 24 hours, you'll pay for 24 hours, and so on. There is no more money that is going to get stuck into your infrastructure. It also offers scalability. So again, even if there is a guesswork, you have under provisioned your hardware for some reason, and suddenly if you're hitting your peak usage and you want to deploy more servers, you can deploy it instantaneously. Because your server capacity will vary according to the traffic, you can increase or decrease your server capacity based on your traffic needs. So it's quite cool feature. So there is a normally feature called auto scaling, which is available in, for example, AWS Cloud. So you can actually monitor your live usage on the servers. You can configure your auto scaling so that whenever your usage is hitting a certain threshold, it will trigger an event, and based on that event, you can add, or you can, for that matter, reduce the capacity of your servers as well. So we are not just talking about scalability in terms of scaling up, you can even scale down. So for example, if you are provisioning 5 server instances and most of your server instances are sitting idle, so you can monitor your environment, and then you can decide that just to give you an example, if your CPU utilization of your servers is less than 25%, then you can terminate one instance, and so on. Or for that matter, if your CPU utilization is hitting more than 80% constant for consecutive period of, let's say, 24 hours period, then you can decide to add one more instance as well. So those auto scaling events can really help you to automate the deployment of your environment based on your traffic needs. And in terms of management, in terms of monitoring, you don't need to invest in any environment for monitoring, or for that matter for management of your servers, because most of the cloud providers, they offer you this compute capacity or the server capacity as a service. So they will monitor your servers, they will manage your servers. So you don't need to worry about any underlying infrastructure. You don't need to invest in any monitoring licenses or monitoring infrastructure to manage your environment. So what is cloud computing? So it is the use of remote servers on the internet to store, manage, and process your data, rather than a local server or your personal computer. So traditionally, all the servers that you would deploy, so you would ideally deploy your servers locally in your own offices, in your own environment, or if you are a big enterprise customer, then typically you will have your own data centers to manage. So we have just talked about cost associated with servers, cost associated with storage, networking, and so on. There are facilities cost associated with it as well. So for example, if you want to deploy your servers in a data center, so you would need to pay for the facilities cost as well. So cost associated with leasing of the real estate where you want to deploy your servers, cost associated with your power, cooling, rack space, and so on, cabling, and so on. So there is lots and lots of other costs associated with keeping your environment in-house as well. But in terms of cloud computing, you can purchase those servers, or rather you can provision those servers, and you will only pay for the used capacity. And since all your servers are going to be deployed remotely, so there is no facilities cost associated with it as well. How you want to access those servers? You can access those servers from the internet, or in case if you are worried about the security part, you can also connect to your cloud environment using private connectivity as well. So for example, you can connect them using IPVPN, IPsec VPN, you can connect them using lease line, you can connect them using MPLS, and so on as well. So what are the different service models which are available in cloud computing? So primarily there are three types of service models. So now most of the cloud providers are coming up with more and more versions of it. Okay, so we have a question from Hemant that in autoscaling, what metrics decide whether our instance is reaching threshold? So in terms of AWS, there are four different types of predefined metrics which are available for us. Those predefined metrics are, CPU usage, then you have, disk read and write, then you have network bytes in and out, and then there is also system checks involved. So these are the predefined or default metrics which are available to us. You can decide which particular metric you want to monitor and what threshold that you want to set. So for example, I gave you an example of monitoring your CPU utilization, because typically it is seen that in case if you are hitting your peak usage, your CPU utilization is the first metric which normally goes high, because your server is responsible for doing a lot of processing, and in that case your CPU cycles will be involved a lot. So you can set your threshold whether you want to add or delete more instances based on CPU utilization, or you want to add or delete instances based on your disk read and write, or you want to add or delete instances based on your network in and network out bytes as well, or in case if any of your servers are failing the system health checks, then you can add or delete instances as well. So there are four predefined or default metrics available, but of course there are options to decide you can also create your custom metrics as well, but that's something that that's not part of this particular webinar. But yes, there are options to define custom metrics as well. All right, so let's move on. So in terms of service models, as I was saying, that there are three types of service models which are prevalent in the market. Of course, most of the providers are coming up with their own versions of this model. So we normally call them as X as a service, but let's focus our discussion on the prevalent ones. So there are three types of models. So one is infrastructure as a service, another one is platform as a service, and third one is software as a service. So let's have a look at each one of these. Okay, so infrastructure as a service, it normally provides your virtualized computing resources over the internet. So as I have said that you can choose the type of connectivity. So even though those infrastructure is available at the cloud hosting providers, and you can connect over internet, you can connect over VPN, you can connect over private connectivity as well. But primarily your infrastructure as a service model will provide you virtualized computing resources. You don't need to worry about underlying physical hardware or physical machines, and it will provide you the abstraction layer from the physical machine. So think of infrastructure as a service. So what is the typical infrastructure that you would have in your environment in your local data center? So you will have some servers, you will have some storage, you will have some kind of networking, you will have some kind of security gears as well. So rather than having all of these boxes or all of these hardware devices on your own, you can put everything on cloud. Now when you put everything on cloud, and if you want to use each of these components yourselves, typically have all these resources available to you, but you can pick and choose what are the resources that you are looking for. Of course all those resources will be virtualized. There are no physical hardware boxes which will be dedicated to you in that case. So for example, you can pick and choose whether I want one server instance, two server instance, or 10 server instance, and whether that server instance will be of a Windows server, will be a Linux server, will be a Unix server, will be an Ubuntu server, and so on. And whether you want the storage associated with it, whether you want to have a magnetic storage, or you want to have an SSD storage, or you want to have an object-based storage associated with it. And similarly, you can decide whether you want elastic load balancer or not, or whether you just want a normal servers and a virtualized firewall or not. So all the services are available to you, but you will have to pick and choose which services you want. So that is your infrastructure as a service. So example, so you will have multiple providers. So you have Microsoft. So the prevalent ones are AWS is of course on top of the Gartner report for infrastructure as a service model. Apart from AWS, Microsoft Azure is something which is really catching up. In fact, the year-on-year growth of Microsoft last year has been 300%, so it is catching up really fast. But of course, continues to lead the infrastructure as a service model in Gartner report and I think AWS has been leading from last 4 or 5 years. Apart from AWS and Microsoft Azure, you also have Google Cloud, which is the recent entrant into this market. You have cloud providers like Rackspace and so on as well. The second service model, which is again prevalent in the market, is your platform as a service model. So even in this model as well, there is no control over the underlying architecture, including OS, storage, server, etc. So infrastructure as a service model, you had the liberty of choosing which server instance you are looking for, which operating system you're looking for, what is the storage capacity you want to attach to your servers. But in platform as a service, you do not get the control over the underlying architecture. So the architecture will be preset for you. For example, that architecture can be a Linux operating system, Apache web servers with a storage capacity of 100 GB and so on. So typically you can call them as runtime environment as well. So the platform as a service model is primarily dedicated for or targeted at developers community who want to, who do not want to spend their time on the infrastructure related issues or infrastructure related decisions. All they want is that I have a Java application and I want to deploy Java application. I have a Node.js application. I want to deploy the Node.js application. So platform as a service model will, give you option in terms of runtime environment. So you choose which particular runtime environment you're looking for. I'm looking for a Java runtime environment. Whatever a Java application would need in terms of underlying infrastructure, that will be pre-populated for you or pre-installed for you. You can just choose your runtime environment, you can upload your code, and your application will be deployed instantaneously. So it is primarily dedicated for developer community or targeted for developer community. In this model, your cloud provider gives the ability to customer to deploy your created application using programming languages, using tools, etc., that are provided by the cloud provider. Again, so if I talk about AWS, so there is a service which closely relates to your platform as a service model. The name of that service is Elastic Beanstalk. So in that particular environment, what you will do is, if you go to the Elastic Beanstalk console, all you have to do is select which application you want to deploy. So there are, I think, 6 applications in the runtime environment which are supported. So for example, there is a Node.js, there is a Java, there is PHP, there are Go, there is Docker, and so on. So you just select the runtime environment, upload the application code, and the moment you upload your application code and click on deploy, it will automatically deploy the underlying infrastructure in terms of the server instances, in terms of load balancer, in terms of your security groups and so on. So you do not need to worry about any of the provisioning requirements for your application. The third service model is software as a service. So as the name implies, this will give you your software as a service. In this particular environment, your cloud providers will lease the application or the software, which will typically be owned by the cloud provider, but it will be provided as a service to the client. For example, Salesforce.com, they provide their CRM software on a cloud infrastructure to its clients. So for example, you can get a CRM application directly from the Salesforce, in fact, they also have their own cloud as well. So you can get the CRM application directly from Salesforce. In this particular environment, you do not get any liberty in terms of what is the platform they're using, what is the infrastructure they're using, or for that matter, whether you need any customization in your software or not, because the software will be deployed and will be provisioned as a standard environment, and it will be given to you as a service. Of course, in terms of charges, your charges will again be based on the usage capacity. But keep in mind that in this particular environment, the software that you're going to use, that software will always be owned by the cloud provider company. You cannot own the software. And also keep in mind the requirements for your data security or data retention as well, because any data which is associated with your software will normally be kept in the cloud. So keep in mind your data requirements as well when you choose your software as a service model. Other examples that I can give you is, so for example, I think we have Gmail for business. So you get your Gmail application for you, but what that application is using at the backend, you do not have any control of it. and you do not even get to customize your application as well, because every user who will opt for Gmail for Business, they will get the same environment, will get the same look and feel of that software as well. So there are multiple options available for software as a service. So for example, Gmail for Business, Skype for Business, you have Salesforce, you also have Exchange as a service. So there are multiple options available for software as a service as well. Okay, so let's do a quick comparison of all the three service models that we have discussed, and the fourth one, of course, if you keep everything in your own environment, we normally call it as a package software. So in case if you want to deploy everything on your own, so you will be responsible for complete environment. So you will manage the networking, you will manage the storage, servers, virtualization, operating system, any middleware, runtime environment, any of your data and any of your applications. So you will be able to monitor, manage and deploy all these infrastructure components. Okay, question from Heyman, that the data which will be generated by the software, it is also owned by the company hosting the software. Well, data will always be owned by you. Of course, the software company or the software as a service provider cannot claim the data that is generated. Of course, the data will be owned by you. But what I'm trying to say is that keep in mind the data that you are going to generate using your software, that data will be stored in cloud service provider. Okay. So make sure that you are following your best practices based on the industry that you are working in, based on the data retention policies that you have. You need to talk to your cloud service provider and understand that what is your data retention policy. So for example, if you're using, let's say, Gmail for Business, or if you're using Exchange as a service, then typically most of the companies have the policies in place which says that you need to keep your mails at least for 1 year or 2 year or 3 year and so on. So you also know that whenever you open your Exchange boxes, it does give you an option or error at times that says that you need to delete your old emails. So that's something that will be decided by your cloud service provider, that what is the data retention policy that they are using. So make sure that you talk to them and understand the data retention policy, that how long your data will be valid for and when will be your historical data be deleted. Okay. And secondly, even if you want to, let's say today you have used Exchange as a service and you're getting that Exchange as a service from one provider, you want to move to another provider. So of course you do not want to lose all your data to the previous providers. So you can copy your existing data and move out of one provider and copy it to the another provider as well. All right. So in terms of package software, so you are deploying everything on your own, you are deploying everything within your environment. So you are responsible for managing everything right from top to bottom. So you are the owner of your application, you are the owner of your data, you are the owner of your runtime environment, or operating system, networking, storage, server, and everything as well. In terms of infrastructure as a service, the cloud provider will give you the underlying networking, the underlying servers, underlying storage, underlying virtualization. But whatever operating system that you want to run on top of your infrastructure as a service model, whatever middleware you want to run on top of your infrastructure as a service, whatever runtime environment you want to run, whatever data you want to run, and whatever application you want to run, all those things will be managed by the application owner or by yourself or by the customer. Cloud provider is only responsible for the underlying physical infrastructure or up till the virtualization layer. So once you have chosen that you want to have, let's say, a Linux virtual machine, so of course there is some networking associated with it, that how that virtual machine is going to connect to the internet, how it's going to connect to the firewall, to the load balancers, etc. All these things is something which is managed by the cloud service provider. All you need to do is you just choose the machine and then you deploy your runtime environment. Maybe you want to deploy Apache, when you want to deploy PHP, etc. And whichever application you want to deploy, you can provision your application on top of it. In terms of platform as a service, so we get a step ahead. So apart from your networking, storage, server, virtualization, even the operating system, the middleware or the runtime environment is something which is preset or pre-populated by platform as a service. You do not get to choose which operating system you are looking for. You do not get to choose the runtime environment variables that you want to set. So if you want to deploy the example that I gave, a Java application, So you will just upload your data. So data refers to the application code, and then you will deploy your application. Now, whoever is using your application, they will generate that data, but you will be responsible for managing that data as well as the application, whereas the cloud provider will be responsible for managing everything in terms of physical infrastructure, in terms of your virtualization, operating system, and runtime environment. If we go for software as a service, so apart from the runtime environment, now in this case even the application is something which is managed by the vendor. So vendor will deploy the application. The vendor here, the cloud service provider, will deploy the application. Even the data will be stored in the cloud service provider model. So even the management of data is something which will be done by the cloud service provider. Okay, question from Hemant, that is AWS just infrastructure as a service, or is it PaaS or SaaS? Well, in terms of cloud computing, normally your AWS is always falls under infrastructure as a service. If we talk about AWS in general, but there are some services which falls under platform as a service model. So I gave you an example of Elastic Beanstalk. Because Elastic Beanstalk gives you the runtime environment, and you just have to deploy the application code on that environment. So that particular service falls under platform as a service model. If we talk about software as a service, there are multiple vendors or there are multiple companies who are using AWS infrastructure environment to provide software as a service model as well. So let's say that you have deployed some application, okay, and in that you have created an application and you are deploying that application on AWS environment. From the AWS cloud environment itself, you are offering your application as a service to your end client, right? So you can create software as a service model or software as a service environment on AWS as well. If I talk about the Gartner report, where they normally rate the different cloud service provider, so AWS does fall under infrastructure as a service model. In terms of software as a service model, typically Salesforce is what is typically called software as a service model. All right. Okay, let's move on. So this is the service model. So again, just to recap, there are three types of service models which are prevalent in the market. They are infrastructure as a service, platform as a service, and software as a service. Now let's take a look at the deployment models. So there are three types of deployment models which are available. So deployment model refers to how you want to deploy your environment or how you want to deploy your applications. So the deployment model is public cloud, private cloud, and hybrid cloud. Let's discuss a little bit more on public versus private versus hybrid cloud. So again, you will use the same service model. So your service model can be infrastructure, can be platform, can be software as a service. Now, where do you want to deploy your environment? You can deploy your environment in a public cloud. So public cloud is something which is available over the internet. So public cloud like AWS, Microsoft Azure, Google, Rackspace, all of this falls under public cloud category. Private cloud is when some of the companies are using their own data center to host their infrastructure. So for example, if you are an enterprise company and you want to run all your infrastructure on your own and you will have your own data centers, then that falls under private cloud. So there are multiple companies. There are companies like IBM, HP, Dell, Rackspace, VMware. There are companies like AT&T, CSC, even for that matter, companies like HCL, Wipro. They all have their own data centers as well. And they normally, typically falls under the hosting companies, I will say. So any of the hosting companies which are hosting your environment or your application or your infrastructure within their own private data centers, that falls under private cloud. Now, whether you want to use private cloud or whether you want to use public cloud is totally your decision, because as the name implies, your public cloud is something which is available and which can be accessed from the internet. Of course, there are some security policies in place and you can make use of that security policies as well. But in case if you are very, very cynical about security and you don't want to host your business critical applications on public cloud, then you can choose to deploy your business critical application on private cloud as well. Whether that private cloud is something which is managed by yourself, which means you have your own data center and deploy everything on your own, or whether you want to outsource that private cloud environment to some third parties. So again, companies like HP, IBM, CSE, companies like HCL, Wipro, TCS, all of these companies, they have their own data centers as well. So you can use the data centers owned by these companies to host your infrastructure as well. That will also fall under private cloud environment. But the most, of course, in terms of pricing, your private cloud environment will be more expensive compared to your public cloud environment. But in terms of security, your private cloud environment probably will give you more security features compared to public cloud. And your private cloud environment will give you more flexibility in terms of where exactly you want to deploy your infrastructure, because you can pick and choose. Let's say that you're working in a US region, or you're working in a European region. So you can pick and choose from the multiple private cloud providers which are available in the market to decide where exactly their data center is located and where exactly you want to host your infrastructure. Whereas in terms of public cloud providers, the public cloud providers have limited number of data centers available to them, and you do not have an option to say that if they have a data center in London, you cannot say that I don't want to deploy in London, I only want to deploy in, let's say, XYZ location where they do not have a physical presence as of now. Whereas in terms of private cloud providers, you can say that I want to choose a company who have a private data center in this particular location. So there may be multiple companies, but some of you can pick and choose which company you want to go for, which have a data center in the location of your choice as well. But as I said, your public cloud providers are cheaper than your private cloud providers, and most of the companies, rather, in fact, they are moving to public cloud these days. But you're worried about the security part. So what you can do is you can start with non-critical application or non-critical environment. You can put non-critical environment on public cloud, and you can continue to run your business critical applications or business critical environment on private cloud. So if you are making use of both private cloud as well as public cloud, then you are following the deployment model of a hybrid cloud, because you are making use of both the models. Now again, as I said, private cloud does not mean that you are keeping everything on a third-party data center. You can also have everything on your own data centers as well. Even if you are keeping your business applications in your own data center and you are moving some of the stuff on public cloud, you are still following the hybrid deployment model. Any companies, as an architect, as a cloud architect, if there is any company who wants to move to public cloud, you will always say that they will follow the hybrid cloud model initially. So typically they will always start with deploying the development, and they will always start with dev and test environment. So they will want to move their dev and test environment onto the public cloud. And once they get their feedback, once they understand the public cloud environment, once they gain some kind of they become more comfortable with the public cloud providers, and they see the benefits of getting associated with a public cloud provider in terms of pricing and so on. Then slowly and gradually they start moving their business critical applications on public cloud as well. Okay, so Hemant is saying that my own data center will also be private cloud, and if that is the case, won't my data be more secure on AWS because they have better security practices in place? Well, as I said, that you can host your applications onto your own data center as well, and you can probably deploy some of the development and test environment on AWS or any third-party public cloud provider as well. In that case as well, you will be following the model of hybrid cloud. Yes, if you keep everything onto your own private cloud, your data will be more private or more secure, because you know your data, you know what type of security measures you want to take. You are in complete control of your data. But at the same time, that's absolutely right that companies like AWS, since they are a public cloud provider and they are hosting big MNCs, they are in fact hosting some of the biggest names in the financial industry as well. So their security practices will be probably more mature than you as a customer. But then I don't know you as a customer, maybe you have more mature security practices as well. Security in terms of public cloud versus private cloud, it is more of a perception, I will say, because most of the customers, they have a perception that if I move my environment onto the public cloud environment, I'm exposing my applications for more security risks. Whereas if I keep everything in my private environment, my applications or my data is more secure. So it is more of a perception rather than reality. The reality is, yes, since the public cloud providers are hosting, numerous, I don't know, I mean, thousands or millions of applications and thousands of customers, so their security practices will be more mature. But at the same time, if you move your environment to the public cloud, the security is not something which is only the responsibility of the public cloud provider. You as a customer is equally responsible for making sure that you are keeping your environment secure. So for example, there are all the features and all the security policies in place, but you need to make use of those policies as well. So just to give you an example, that when you launch a server instance in the cloud, you need to select the security group. So security group is nothing but it is a virtual firewall which is given to you. Now, if you keep that virtual firewall open to the entire world, so if you are accessing all traffic from the internet, then of course you are putting your application or your server at risk. And if that server is getting hacked by someone, you cannot blame that my server got hacked because it was on public cloud, because AWS has given you the feature of security group, but you need to deploy that security group. You need to select which ports I want to open. If you are gonna keep everything open to the entire world, then of course you are putting yourself at risk. So security, normally we say that the security is something which is a shared responsibility model between the public cloud provider as well as the customer as well. And this is where it is very important to understand that even if you put your environment onto public cloud, you are not secure by just putting it on AWS and saying that it is the biggest cloud provider which is available, and probably it will be more secure, because you are equally responsible for it. Okay. All right. So what are the advantages of cloud computing? The first is there is no upfront cost. Anyone would move to the cloud, whether it is a private cloud or a public cloud or a hybrid cloud. Anyone would only want to move to the cloud environment because it gives them a lot of saving in terms of their IT or budget, because there is no upfront cost associated with it. So you are directly taking your capex out of your IT budget, and you're converting your capex into an opex. It gives you better security. So again, we have discussed that most of the public cloud providers, since they are hosting so many companies, so many infrastructure, so their security practices are more mature than you or any of the other private cloud providers as well. There is no maintenance associated with your infrastructure. So all your infrastructure is maintenance free because it is something which will be maintained by the cloud provider. Anywhere access, so you can access your environment from anywhere. So let's say that you are running your test and dev environment in the cloud. So rather than accessing it only from the company, you can also access it from home or from any location as well. Fast implementation. So we have already discussed the typical, life cycle of from ordering a server to provisioning of server is normally it takes 4 to 6 weeks or sometimes 8 weeks as well. Whereas in terms of cloud, the moment you have got your approvals to deploy the servers, you can deploy those servers in a matter of minutes rather than 6 to 8 weeks, because there is no provisioning, there is no procurement that needs to be done, there is no capacity planning that needs to be done. All you need to do is get an approval from your business unit that I want to launch 2, 3, 4, or for that matter 1,000 servers, and then you can just click on your AWS console and launch those servers. You do not need to worry about whether that infrastructure is available or not, whether that capacity is available or not, or whether who will deploy those servers in terms of racking, stacking, and so on, because everything is done for you by AWS. It also gives you instant scalability. So as I have discussed, the auto scaling part. So rather than guessing your application needs, rather than guessing the infrastructure capacity that you would need, you can start with the minimum server capacity that you are looking for and start monitoring your environment. The moment your environment is hitting your period or getting more traffic, it will automatically scale up, or it can automatically scale down as well. So it gives you instant scalability without any user intervention as well. So what are the use cases? So there's a company called Twilio which is using cloud computing platform which helps developers to communicate between their application using messaging and voice communication APIs. So Twilio is something which is used by Airbnb, Netflix, Uber, and many more other companies as well. Twilio has deployed their environment onto the cloud. So they have moved from their environment to the cloud, which has resulted in reduced latency and easy scalability. So Twilio is kind of a messaging service which you can use to send text messages, voice communication, and so on. So when it was not on the cloud, scalability was something which was very, very difficult to achieve. So of course, they faced a lot of stress in terms of scaling the environment up as and when their application got more popular. And of course, it was very expensive to keep on buying more hardware and provisioning those hardware to, manage your application, because they want to manage their application, not the infrastructure. So by moving on to the cloud, they have reduced latency, and now, scalability is very, very easy to achieve as well. Some of the fun facts. So Twilio, as I said, is using AWS at its backend. It was started in 2008, and it is all in on AWS to power its cloud scale communication apps globally. It uses AWS to deploy an average of 30 features in a day and still maintain 99.999% of availability. So imagine, deploying those 30 features in a single day on your own private environment or private servers. Do you think it would be possible for them to test these many features in a single day? Because in that case, you would definitely need to have, first of all, a lot of infrastructure capacity, and secondly, your skill set in terms of system resources at your disposal as well, so that you can, in case if any of the issues is happening at the infrastructure layer, those infrastructure layer issues can also be handled very quickly. But rather than focusing on increasing their IT budget by hiring more people and buying more servers, they have moved on to AWS. They do not need to worry about the underlying physical infrastructure. They just focus on their application, and they know that the infrastructure will always be available for them. So they have been able to test on an average, deploy and test 30 features in a single day, and while still maintaining 5 nines of availability for their application. All right, so I think we are coming at the tail end of our course or our webinar. Now, if you are convinced by now that I want to start my career, or I want to probably enter into cloud computing, and you're still confused on how do you want to get started with it, especially on AWS. So first of all, you need to understand that there are different cloud providers available in the market. So some of them I've already named. So you have Azure, as you have AWS and Azure leading that particular market. Then you have Google Cloud, which has recently come up, or not recently, but probably it is catching up a lot. Then you have Rackspace, DigitalOcean. Then you have IBM Cloud, VMware, Terramark, Joint, and this is just a subset of the cloud computing market which is there. If you just search on Google what are the different cloud providers, I'm sure you will see that there are tons and tons of cloud providers which are available. So for example, I can name the few. So apart from IBM Cloud, you have cloud from Salesforce, you also have cloud from HP, you have cloud from Dell, you have cloud from telecom companies like AT&T, Verizon, you have cloud from companies like CSC, HCL, Wipro, TCS, you have cloud providers from Box as well. So there are multiple cloud providers which are available in the market. So if you are entering into this particular segment, you are sure to get opportunities in different cloud providers as well. A quick comparison on AWS versus Azure. So Azure, as I said, that is something which is catching up really fast, but again, still AWS is a leader in the recently issued Gartner report as well, and it is leading by quite some margin. Azure, in terms of server capacity, it is again very less compared to the server capacity which have been deployed in AWS. In fact, your AWS has 6 times the server capacity of all the cloud providers combined together. So including your Azure, Google, and so on. The number of servers which are deployed on AWS is approximately 6 times of all the servers deployed in all the cloud providers. In terms of market share, Azure is at 11% of global market share, whereas AWS leads the pack with 31% market share. Again, 31% of the total market share of the cloud computing market. So imagine there are thousands and thousands of cloud providers who are competing in this one, but AWS is currently owning 31% of the total market share of cloud computing. AWS was started in 2006, whereas Azure came into picture on 2010. In terms of servers, AWS charges you for per hour usage, whereas Azure charges you for per minute of your usage. So in terms of pricing, you may see that probably there are some features. In fact, there will always be a price war going on. So at some time, In some of the features, probably AWS will come in cheaper. On other features, probably Azure will come cheaper, and probably Google Cloud may come in cheaper than both of them, and in some cases as well. So you literally have to pick and choose which service you want to be interested in, and which service will give you more features and more availability and durability. And then you can also decide on the price factor as well. AWS, as I said, it wins, and it wins by quite some margin. So as you can see, it has greater market share, 31% of the total cloud computing market. It has a more mature model of infrastructure since it is, it was started in 2006. Of course, their practices have been, more mature compared to, other cloud providers like Google, Azure, and so on. It has more server capacity. So imagine there are lots and lots of servers, but just to give you a rough number, if there are 1 million servers which are deployed across all the cloud providers which are available in the market, then your AWS alone is running 6 million servers. And I'm pretty sure they are running more than 6 million server. And it offers you better pricing as well. So in terms of pricing, as I said, there is a price war going on between different cloud providers. So maybe you will see that if you do a apple to apple comparison, maybe you will see that there are some services on which AWS is cheaper, there are some services where Azure is cheaper, there are other services where maybe Google is cheaper. But you need to take a holistic picture. You need to understand that if you want to deploy your environment on any cloud provider, then you need to make sure that of course you cannot keep moving from one cloud provider to another. So you need to take a holistic picture in terms of which cloud provider offers you a complete solution and better availability and better scalability and ease of usage before you want to move to that particular cloud. In terms of market demand for AWS, so if you see, this is the solution architect job posting. So we are talking about AWS solution architects. In 2016, there are 35% jump in the number of job posting which is having a keyword of AWS certified solution architect in the job description. So there are 35% more jobs which needs this kind of skill set. So if you are gonna get this skill set, you are pretty sure to get ahead of the pack in terms of making sure that your career is on the right track. Now, if by this time, if you have decided that you would want to learn AWS, so what are the options available to you? So Edureka offers a very, very structured training for you to get into, get your hands and feet dirty in AWS. So there is an AWS Solution Architect Associate level course which is provided by Edureka. So just to give you a quick recap of what that course content involves. So it starts with introduction and getting started with AWS, where we talk about what are the global infrastructure which is available in AWS. So the concepts of global infrastructure in terms of regions, availability zones, in terms of your caching locations or your edge locations, and how AWS uses those different features to give you a highly available, scalable, and a secure infrastructure. Then we move on to Amazon EC2. So EC2 is your server instances in the cloud. So we normally call it as Elastic Compute Cloud. So just to keep it simple, so this is basically your virtual machine in the AWS cloud. We call it as an EC2, which you can call it as a VM, you can call it as a server, you can call it as a server instance as well. So of course there are a lot of features in EC2, something which is worth exploring. Then we move on to the storage services and AWS CLI. So storage services include services like EBS, which is Elastic Block Storage, services like S3, which is Simple Storage Service or an object-based storage. Elastic Block Storage is your block-based storage which you can use to deploy your databases, deploy your file systems, and so on. Then we also talk about different types of storage classes which are available in S3. So we, services like S3 storage, standard storage, S3 infrequent access, and S3 reduced redundancy storage, and storage options which are available for archival purposes. So storage options like Glacier, and in how you can use different services within AWS for moving your workload from your data center to AWS. So we talk about services like storage gateways. We talk about services like AWS import and export, which helps you in moving or migrating your workload from your environment to the AWS cloud. Then we move on to next section, which is about the networking in AWS environment. So we talk about VPC, which is your virtual private cloud in AWS, which tells us how you can create your own little segment within the public cloud, which gives you even more security. And then we discuss the connectivity options in the cloud. So things like how you can create a VPN connection in case if you do not want to connect over internet, or how you can use direct connect for connecting to AWS using private connectivity like leaseline, MPLS, and so on as well. There is a section on databases. So there is a service called RDS, or Relational Database Service, in the cloud, which supports 6 types of database engines like MySQL, SQL Server, Oracle, Postgres, MariaDB, and Amazon Aurora as well. We explain how you can use these services to deploy your database in the cloud environment, and what are the different features which are associated with launching your database instance in the cloud. So features like creating read replicas, creating your multi-AZ databases for highly available and secure databases as well. Then we move on to the Elastic Load Balancer, or ELB, and autoscaling. So as I have explained that you can use the autoscaling feature to automatically scale up or scale down without any user intervention involved. So this is where we integrate the different concepts of monitoring your server environment and then using those monitoring metrics to create some kind of events or some kind of thresholds, so that whenever your metrics reach a certain threshold, it will trigger an event, and based on that event you can configure your autoscaling policies to either add or delete your server instances in the AWS cloud. So that gives you automated environment in terms of your traffic needs. Then we move on to the service called Route 53, which is a DNS service in the cloud, and we talk about the different management tools which are available to us, like CloudWatch, which is basically a monitoring service in the cloud. Then we have different services like application services like SCS, Simple Email Service, SQS, Simple Queue Services, and then you have SNS, which is a simple notification service, something that you can use to send a notification to your IT admin guys if something goes up or down in your environment as well. There are services like Lambda, which is an event-based programming, so that whenever someone is, for example, uploading any content on your S3 storage buckets, then it will trigger an event and you can use that event programmatically take some action on as well. Then we talk about Elastic Beanstalk, something that I have talked in platform as a service model. So this is basically a platform as a service kind of model where you just select the runtime environment that you're looking for, and then you upload your code, and with just a click of a mouse you can deploy your applications. Then we move on to some of the more automation stuff. So things like OpsWork, CloudFormation, the security features in the cloud, and identity services. How you can make sure that you can use identity services. We call it as identity and access management services, or IAM, to manage your user authentication or access control in your cloud. So there are different concepts like how you can create different users, how you can create different groups, how you can assign those IAM users into groups, and how you can assign different roles to the group or user level so that they can access your AWS cloud securely. And lastly, of course, we have a mock test and doubt clearing session as well. So after completing all these services, we will give you some kind of tips in terms of how you can approach your AWS exam, how you can clear those exams, and what are the different reference material that you need to go for before you attempt your exam. So primarily more of an exam tips, and of course a session which is kept to clear any of your doubts on any of the previous modules that we have covered. So as you can see, it's quite a structured way of delivering a session. So there's a structured training which is available from Edureka, which I'm sure that you guys would love to enroll into in case if you want to get started with AWS. All right, so let's quickly recap what we have learned so far in this webinar, or what we have covered in this webinar. So we started off with what is cloud computing and why cloud computing. So cloud computing, as I said, that it's a service where you can deploy your infrastructure remotely onto the cloud environment, and then you can access that infrastructure from internet. And AWS, we have seen, is a market leader in this particular segment with 31% market share globally, with 6 times more server capacity being run in AWS cloud compared to other cloud providers. Then we talked about different types of services models. So there is infrastructure as a service model, platform as a service model, and software as a service model. And which particular service models fits for which categories, and what you will be responsible for in those service models as well. Then we followed it up with deployment models. So there are 3 types of deployment models, which is public cloud deployment, private cloud deployment, and hybrid cloud deployment as well. So public, in case if you want to move to public cloud providers like AWS, Google, Microsoft, and so on. private in case if you want to use some other third-party companies, and hybrid in case if you want to use both, a mix of both. We also had a look at the different cloud providers which are available in the market, and lastly we covered the structured training which is available for students to get started in AWS from Edureka. So this will conclude our session for today. Thank you so much for your time and good luck.